Hi, social studies students. Hope you're having a great day today. I've got my spooky friend up here to keep us company and some artwork for my kids on the wall. Hope you enjoy a little extra background today. Anyway, today we're going to start a movie that's called History of the World in 2 Hours. I think you'll enjoy it. It is a theory about how the universe was created and how the earth has come to be and how humans have come to be. And I want you to remember that we're thinking about that as social studies students. Why are things the way they are? Why are humans the way they are? Why have we come to this point in our existence? And this movie is just giving you some ideas and some background knowledge on that. There are theories in this movie, so you may or may not agree. People were not alive during a large part of this movie that they show. They're only using primary and secondary sources as a way to help explain some ideas. So, for example, we say Big Bang Theory because we don't know for sure. No one was alive then. We're only putting together the pieces of evidence that we have to be able to possibly explain things in that way. So, the Big Bang Theory is a theory, and you may not totally go along with that or believe that, and that's okay. But I'm asking you to keep an open mind on this movie and to hear what the scientists have to say. And speaking of scientists, there may be some things that you notice in here that you'd like to be able to do more of. There might be a hobby for you to investigate something more, maybe a career choice down the road. I'm not sure, but keep your mind open to the ideas of what these scientists explore. There's lots of different types of scientists in social studies and history, so you might find something that interests you as you're watching this movie. When you're watching this movie, you're not just completely sitting back and relaxing. You are going to be doing a little bit of thinking and working. So, one thing to help you keep on track is we're going to ask you to be filling in this worksheet. The worksheet is actually more of a study guide. So, to help you keep track of some of the information, they're going to give you tons of information in this movie. So, we're going to pick out some of the pieces of it, some of the ideas of the lineage and the time frames to help you understand things a bit better. So if you look here, you'll see that it starts at 13.7 billion years before present. That's a long time ago. They're going to go through the Big Bang Theory. Okay, so we're going to start there, and then it's going to continue down. Today, you're going to stop at 4.4 billion years before present. We're just going to fill in those sections right there for today. The rest you'll hold on to for the rest of this learning period with the movie. And then when it's time for you to study, you'll have your own study guide. Every day, you'll fill in a little bit, and then the next day, we'll correct it together. So let's just say that you're working on this and you're watching the movie and you think you know an answer and you're trying to jot it down, but gosh, you're watching and you're interested in the next thing in the movie. If you don't want to miss it, that's okay. At the end, your teachers will give you a little work time to fill those in, maybe compare answers with the buddy next to you. And then the following day, Miss Richards and I will go over the answers. So then you can correct yourself. Oh, shoot, I had that wrong. I forgot. I mixed that up. You can erase it and fix it up and have your study guide perfect for when you're studying for the test. This page will be for the day after today. And then this down here is a little word box. So I'm going to read through these with you so you can become familiar with these words and be kind of listening in the movie. These must be important words if they're in the word box, I would think. So keeping an ear out for these. So right here we got hominids, stone, Permian, asteroid, hands, legs, grasslands, universe, 70%, Cambrian, sun, supernovas, ocean, earth, moon. So this is the box for today, and this will also be the box for tomorrow, the next day that you watch this movie, and that will finish off these two pages, the front and back of that page. So your job today is to keep an open mind, to watch this movie with an expectation of learning some new things and learning some new ideas, and to then by the end of class have this sheet filled out on the front page so you can use it as a study guide. I will then start the movie. Well, actually, what I'd like you to do first is to read through all of these so you're kind of familiar with them as the movie's playing. Then your teacher will start the movie, and then after the movie, you'll have some work time. And that should be good for today. I think that we'll be able to get through that, and I think that you'll enjoy this movie. And like I said, kind of just be a good listener and thinking about new ideas and what questions you might have as you're watching this movie. A few things to know, a few things to look for. Think about the ideas of the tilt of the earth and the seasons. Think about climate. Think about oxygen. Think about the moon. The moon is going to be important in this first section here, and I'm going to ask you why tomorrow. So see if you can identify that. Okay, boys and girls, go ahead and read through this first sheet so you're kind of familiar, and then your teacher will start the movie back up and play that, and then you have some work time at the end, and then we'll continue on tomorrow. Hope you have a great day. Okay, boys and girls, this is the beginning of the movie, so you've already read over that first page and you're ready to start listening and being good listeners. We'll watch about 20 minutes today, then we'll pause it and we'll continue on after that. I'm going to get rid of my face and I'm going to make this big for you, and then you'll know what to do after that. When the 20 minutes are over, you'll stop it, fill in your sheet, and if you have any extra time, you guys can watch CNN or read or work on other assignments depending on what your teacher wants you to do today. Okay, have a great time listening. I think you'll enjoy it. Talk to you tomorrow.
The entire history of the world. Now, what if we told you we could do it in just 2 hours? We're going to tell the whole story, from the Big Bang to the present day. How the planet prepared for the rise of man. How the Stone Age led to the steam engine. How the first seeds sprouted into cities and civilizations. Everything is connected, and the path leads to you. It took history 13.7 billion years to unfold. We'll show you everything you need to know in the next 2 hours. This is our infant universe. Everything that will ever exist, everything that will ever happen, all begins here, within this tiny bundle of energy, smaller than an atom. And right now, history as we know it is about to mysteriously begin. For reasons we may never know, our universe suddenly erupts.
In a millionth of 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 a second, it went from a size smaller than an atom to bigger than a galaxy. Whoosh.
What you're seeing is energy, and it's one key to understanding everything that will unfold in the next 2 hours. Within a fraction of a second, the Big Bang creates all the energy that will ever exist. All the energy that will power the stars, that will fuel anything that ever lives. All the energy that you will ever consume dates back to the beginning of time.
When you put gas into your car, you're tapping energy that was created during the Big Bang. You're tapping the energy of the universe itself.
We're only a few minutes into our 2-hour journey, but already 380,000 years have passed. You are about to witness the birth of your original ancestors, the first atoms. This is hydrogen. The universe will use it to make everything in the world around us.
Hydrogen is like a baseball team. You say, what player do I want to start my team with? Well, if I want to start a universe, I want to start it with hydrogen. Because from that, with a lot of heat and a lot of pressure, you can build more kinds of atoms.
The first atoms blast through the early universe. And luckily for us, they don't spread out evenly. Because in those tiny pockets with more atoms, gravity, the great sculptor of the early universe, begins to work its magic. The first galaxies are beginning to form, revealing a timeless secret of the universe. Throughout history, whenever more matter and energy can be drawn together in one place, more complex things can emerge.
We have all of these urban centers around the planet where so much creativity, so much art, so much science, so much culture came about because of all these opportunities for things to interact with each other.
Really, in a sense, where there is stuff, new stuff can develop, and where there isn't anything, nothing much can develop.
"300 million years after the Big Bang, inside of forming galaxies, gravity continues to squeeze together clouds of gas and dust, causing pressure and heat to violently rise. When the temperature reaches 18 million degrees Fahrenheit, hydrogen atoms slam together, creating a new element, helium, and radiating bursts of energy. The first stars are born.
Suddenly, there were these new beacons of light shining forth, pouring energy into the universe. Let there be light.
But something is missing from this early universe. There are billions of stars, yet not a single planet. To form planets, and eventually people, to take the next leap that would make all of history possible, the universe needs more to work with than just hydrogen and helium.
The complicated elements, the heavier things that we build stuff out of, for example, iron or life built out of carbon and things like that, they're actually manufactured in stars.
We may see stars like our own sun as sources of light, but there is something bigger happening deep inside. Stars are element factories. They fuse hydrogen into helium, helium into lithium, forging 25 of the most common elements we'll need to live, including carbon, oxygen, nitrogen, and iron. So, more than 12 billion years ago, stars are already creating the element that will spur the Iron Age, allow for the building of cities, and the creation of some of mankind's most famous monuments. But a look at the Statue of Liberty reveals the next challenge awaiting the early universe. While the statue's frame is iron, her skin requires an element too heavy to be made in stars. For Lady Liberty to have material for her skin, for there to be gold for wedding rings, or uranium for nuclear reactors, some elements had to be created another way. Stars don't have enough energy to do the job, but if the element factory isn't powerful enough, how about blowing up the factory?
Just a few million years after the first stars formed, some of them exploded. Wham!
These explosions, known as supernovas, are the biggest blasts in the universe since the Big Bang, providing the extra boost of energy needed to fuse heavier elements. In the fiery blast of their own destruction, stars create uranium, gold, all the rest of the elements that will fill our world, including copper.
The periodic table of the elements is really sort of a library of matter in the universe, those are your building blocks. Everything is coming out of that particular chemistry set. Supernovas are absolutely necessary for us to be here. We have iron in our blood. We have little bits of old supernova, therefore, just floating around through us. We are all stardust.
Copper and tin, Bronze Age. Without supernovas, there's no Bronze Age. Go to any supermarket and buy a multivitamin. And go and look in the ingredients. You'll find copper, you'll find zinc, you'll find selenium. You'll find all sorts of elements that can only be made in a supernova.
The elements made by stars will become the seeds of life on Earth and the drivers of human history. But the journey has just begun. Before there can be life, the universe has to build us a suitable home. To build a proper house, you have to assemble the right materials all in one place.
Now, when planets form, it's the same thing. It's the materials that you have at hand that's going to dictate the kind of house that your planet's going to be.
To get enough of the right material in the right place all at once takes a very long time. Over the next 8 billion years, more than half of history as we know it, the element factories continue their work. Stars explode and are reborn. Each generation with more heavy elements than the last. Until 4.6 billion years ago. Finally, there are enough materials gathered for the next step on the path to us. A new star is born. This is our sun. It's so massive that it's gathered up 99.9% of the gas and dust in the solar system. But there's still just enough left behind for gravity to build some other things, like planets. The third one out from this star will be our home. By the time Earth emerges, just over 4.5 billion years ago, 2/3 of the history of the universe has already passed. The first sunrises sweep across a foreboding alien planet. A world spinning so rapidly that a day lasts only 6 hours.
When you go back to the early Earth, right after the planet formed, you really have to think of the Earth as another planet. The sun would have looked out over a hellacious scene of just molten lava. In places, you would see rafts of black volcanic rock.
Within the liquefied rock, the elements are all in a jumble. Something has to bring order out of this chaos. And once again, that something is gravity. Lighter material drifts toward the surface and forms a solid crust, while heavier material sinks toward the center, forming a molten iron-nickel core. This churning liquid metal creates a magnetic field that reaches out into space. Like a force field, it will protect our future home from the sun's deadly charged particles. Soon, this magnetic field will allow for life to grow, and later guide the explorers who will connect two halves of the world. But for all this to unfold, the Earth will need a critical partner. Four and a half billion years ago, an object the size of Mars smashes into the planet at 25,000 miles per hour. Earth swallows up much of the impactor. but a spray of molten debris is whipped off into space. Within as little as a year, gravity gathers this debris into a secondary sphere in orbit around the Earth, where it has been ever since.
The formation of the moon was an incredibly important event in Earth's history.
And in fact, its creation over 4 billion years ago is really important to the Earth's climate today.
The moon keeps Earth steady. Its gravitational pull prevents the planet from wobbling, saving us from wild climate swings. And the collision that formed the moon leaves Earth tilted on its axis, giving the planet a key ingredient to life: seasons.
Having seasons is very, very important for the evolution of life on the Earth. And having some stability in the tilt of those axes, that's very, very important also for maintaining life on the Earth.
The moon's gravity also begins to slow Earth's rotation, which will eventually lengthen our days from 6 hours to 24. $4.4 billion years ago. It's too hot on Earth for liquid water to exist, but there's water vapor, steam in the atmosphere. The trick is how to get it out of the sky onto any world where you hope to have life. A little rain must fall. For millions of years, as the planet cools, rain pours down, forming puddles, lakes, and eventually our oceans. By 3.8 billion years ago, our planet has a moon and permanent oceans. But it hardly resembles the place we now call home. To become the stage for all of human history, Earth needs an oxygen-rich atmosphere, fertile continents for people to discover and develop. Who will create our modern world? There's 1 trillion of them crawling on your skin right now. We're telling the history of the world in 2 hours, from the Big Bang to the present day. And our modern world holds important clues to the story. In fact, structures like this hide a mysterious link to the first life on Earth. $3.8 billion years ago, beneath the surface of our primeval oceans, a revolution is taking place. 6 simple elements, including hydrogen from the Big Bang, and oxygen, carbon, and nitrogen created by stars, have combined to form the key substances that will make up all life, including us. The most spectacular is DNA. Within its spirals hide the secret codes of life. 700,000 years after the planet first formed, life on Earth begins. We stand not on the shoulders of giants, but of tiny organisms, bacteria.
We're very egocentric. We think that we animals run the world, but in fact, we are very late entrants. It was an empire of bacteria long before animals. Animals come along, and we like to think that we wiped out that empire. Well, we would be dead if we wiped out that empire. I have within me an entire zoo of bacteria.
In fact, each one of us has more bacteria living in our bodies than there are people on the planet. For billions of years, microbes like these will have Earth to themselves. Like our infant universe, the first life is small, simple, and full of possibilities. The secret of how it explodes into all the incredible forms we see today, including us, goes back to the beginning of time. As we've seen, all the energy that will ever exist was created in the Big Bang. All creatures need to grab their share of this energy to survive. The more we harness, the more efficiently we use it, the more complex we can become. And almost all of our share of the Big Bang's energy is beamed to us by the sun. 2.5 billion years ago, some very special bacteria figure out how to consume the sun's energy to live. In doing this, they also create the most important waste product in the history of the world: oxygen. Soon, oxygen will remake our world. But first, it has another important job to do. Earth's ancient seas are full of iron particles, and everyone knows what happens when oxygen meets iron.
Here I'm a little bacterium. I've produced this oxygen molecule, and here's a big piece of iron clump. I rust it.
This rusted iron collects on the seafloor. Billions of years later, these huge deposits will be raised up to become major sources of the world's iron and steel.
It was these iron deposits that later on drove the Industrial Revolution.
In this way, the Brooklyn Bridge and the other early landmarks of the Industrial Age are a direct link to some of the first life forms on Earth. Once there's no more iron left in the sea to rust, these ancient bacteria have a mission to complete. They create so much oxygen that it fills the oceans and escapes into the atmosphere.
And from then on, we have a very different planet from all the other planets in the solar system.
Now, life takes a giant leap. For the first time, some bacteria learn to live on oxygen. Every human breath is a ritual. 2.5 billion years old.
Life tends to stick with what works, even over the course of billions of years.
Oxygen is a game changer. By taming its power, life has found a better way to energize itself. 20 times more efficient than anything used on Earth before. What life does with all this new energy will be the story that leads to us. Over the next 2 billion years, life becomes more complex. Skies become blue, and so do the oceans that reflect them. Large, solid continents appear. Earth is beginning to look more like the place we now call home.
Okay, boys and girls, that wraps up today's part of the video. Go ahead and take some time to fill in the worksheet with the answers that you think best fit those blanks. And we'll correct them tomorrow, so don't be too concerned if you don't know the answer for sure. We'll continue on at that point. Thanks and have a great day.